Hello learners, welcome to Education Online program. I'm teacher Willa Lucia. In our previous lesson we learned a lot about the velocity time graph, how to get distance under velocity time graph, how to calculate the retarding force when the mass of the object in motion has been given. So we learned we used so many methods like the equations of motion. We also use the area of any figure or the shape to find the area covered by any object moving. So today we're going to look at something different, which is known as motion under gravity. Motion under gravity. So if you don't find it as motion under gravity, it can also be called we can say it is the falling body. So whenever you find this falling body, they're also referring to the motion under gravity. So you find that under gravity there are two major different types of motion. So we have the free falling object, and then we have what is known as the projectile. So these are the types of motion under gravity. So we are talking about free falling objects. Then we have the projectile. But for today, we shall take one of those and we go through it. So we shall learn one at a time. For today we shall be talking about the free falling objects. So if you're talking about the free falling objects, what do we mean by this term? Free falling objects. You see that in layman's understanding, if you look at free falling, someone might be thinking that it's just any object coming from up. Like, let me throw this. When it's coming down like this is free falling. That is the layman's understanding, but it is actually not the case. In this term here, when we are referring to free falling objects, these are objects that are experiencing the force of gravity on them. You see, a body can be moving upwards and experience this force of gravity. It can also be referred to as free falling. So if the object is even coming down, it is also falling downwards. So that one does not mean that if you talk about free falling, it doesn't mean that only the object must be coming downwards. So we shall say that our free falling object is a motion of a body under the action of gravity. Let's take a look at this example. I have my tissue paper here. I am going to throw it up. Let's see what happens. You see that when I throw it from my hand up, it still comes down. What if I just hold it from here and leave it? It goes down. This time round it has not gone up. Why? Because when I threw it up, I've given it an initial velocity, and the initial velocity I gave the tissue paper was not 0. It was greater than 0. That's why you see that it's in position to move and then come downwards. And why does it come downwards? You'll see that when it goes up, it reaches a point that is called the maximum height. So that means that the initial velocity I've given this tissue paper up to go upwards, it will make this velocity reach a maximum height. So when it reaches the maximum height, it will come down. So what happens when it reaches maximum height? At maximum height there, you find that your final velocity is equals to 0 also, because there it is going to be changing its velocity to come down, downwards. So what happens when I just hold it and then leave it? I'm just going to throw it from here. I've not thrown, actually, I just pulled my hand off, and then you see that it goes downwards. If it is like that, that means that the initial velocity I had given this tissue paper is what? Is 0. The first one when I threw up wasn't 0. But when I just leave it from this point to go down, that means that my initial velocity at over this is actually 0. So you'll find out that there are two motions here. This one is going up and coming down. It goes up and then comes back to my hand. That means that there is acceleration. The body was accelerated. So the acceleration is in two ways. You see that it accelerated upwards and then accelerated downwards. So the moment this tissue paper is going up, that means that there, the acceleration, we are giving it what? It becomes 0. Our acceleration becomes 0. I mean negative, sorry. Becomes negative. Why is it negative? Because when I am taking it upwards, I mean it's negative. So that means that when I am taking it upwards, it is moving against the action of gravity. Because gravitational force acts downwards. So that means if it is going upwards and the other one is coming down, it is something like this. My tissue paper is going upwards and acceleration acts downwards. You see that the two are acting in the opposite direction. That's why there we are giving it the negative. Then you see that what if it is coming downwards? When it is coming downwards, the body is accelerating with a positive, at a positive rate, because there it is not against the gravity. Then you will find out that this acceleration that is being given to the body that is falling freely is what is known as the acceleration due to gravity. So it is written as G. This time round, not A, but G. So that is the acceleration due to gravity, the acceleration we are offering the body. So we are going to see how we are going to get this G and fixing it in to have it in the equations of motion. So let's see this. If we say that our A is actually, our acceleration is actually the acceleration due to gravity, how is that true? Let's take a look at this. From Newton's law, we say that our force, and this is from Newton's law, says that our force is equals to what? The force is equals to mass and then the acceleration, not the acceleration due to gravity. But how do you get the force on a body? You see that the force acting on this body when we are bringing it down, when it is falling, we said it is the acceleration due to gravity force acting on it. So what is this force? It is the weight of the body, because it's this weight that is trying to pull the body back downwards. So you see that our force is also equals to what? Is equals to the weight of that object. So if force is actually is equals to weight, let's look at this. What is weight equals to? We shall find out that our weight is equals to the mass of the body and the acceleration due to gravity. So it is this mass of the body and the force that is pulling it back downwards after you take it upwards. So yes, if it is like that, let us look at this. We are having our force, we are saying is equals to weight. We have the value of force here, and we have the value of weight, which is right here. What happens is that, let us try to substitute where there is force. We take the value, which is the MA, and substitute it where this force is. We shall have it as our MA is equals to the weight. What is the weight here? The weight is the mass of the body and acceleration due to gravity. Because you see that if this is our object, it is falling from upwards. It is the weight acting downwards. So we shall have it as our mg. You see that this m here, this mass is equals to that mass. It's the same. So if we divide through by this mass, we see that our mass will cancel with this, and we shall cancel that. We shall have our A is equals to g. So meaning that the acceleration with which the body is moving is known as the acceleration due to gravity. But for linear motion in the straight line, you find out that the acceleration is not acceleration due to gravity, but it is accelerated at this. They give it A instead. Because that body there in linear motion is not experiencing what is known as the acceleration due to gravity when it is in motion. So you see that when you want to calculate the free-falling objects, there are two things for you to consider. The motion of the body. Is it moving upwards or it is moving downwards? Because these two, if it is moving upwards, you see that there will be a slight change in the equation. And when it is coming downwards, there is also a change. The change there just comes because of the movement against the gravitational force. So you see, when the objects are coming downwards, that means that our acceleration due to gravity is positive. But then if it is moving upwards, the acceleration due to gravity becomes negative because it is moving against the gravitational pull. So let us try to look at these equations of motion. We are going to compare from what we had last time. We said in linear motion, let's see our first equation of motion there. Our first equation of motion was V is equals to U plus A plus AT. If it is like that, this time round, with acceleration due to gravity being the only force acting on the body, we shall say that instead of having A here, our acceleration due to gravity is what we shall introduce here. We replace our A with a G. So, but then if we replace like that, we also have to take note of the movement, the direction taken by the body. So let us have this idea upward free falling. Can have it as falling, and then we have downward falling. So how will the equation look like for the first equation of motion when the body is falling upwards? We said free falling does not mean only the body coming downwards, but as long as there is action of gravity acting on the body. So we shall say that upwards, our acceleration due to gravity becomes a negative. So we shall have our equation, instead of this, we shall be having our V is equals to U minus GT. This time it is not A, but G. What if the body is coming down back to the center of the earth? what happens is that our g is positive. So we shall have our equation as v is equals to u plus gt. So you see, this is the difference we are having here. If you're using the first equation of motion in free falling, so you see the directions will give you actually which sign is right. Let's look at the second equation of motion. We are having our second equation as s is equals to ut plus a half at squared. So if we have that, what if the body is moving, is falling upwards? What happens is our a here turns to g, and then it is moving against the action of gravity. Our positive here turns into negative because we are multiplying a negative number on this side here. So we shall have it as our s is equals to u t minus a half gt squared. So if it is coming downwards, we maintain the positive sign. So we shall have it as our s is equals to ut plus a half gt squared. So this is our second equation of motion. So this is the second equation of motion we have there. Let's look at our last equation of motion. So, and how we shall have it in free falling objects. We shall have our v squared is equals to u squared plus 2as. That is for our motion on straight line. So now this one, when it is a free falling object, we shall have it, this one is upward, so we shall have it as our v squared is equals to u squared minus 2gs. So we shall have it here as v squared is equals to u squared minus 2g plus 2gs. We are having these two differences because you can check on the heading alone. We are saying upward falling, and then there is the downward falling. So you should always be keen about that, the direction to which the body is moving, whether it's upwards or downwards. So you'll see that this one here applies for body, where we say that the resistance, air resistance, and the friction is negligible. Because if we talk about the air resistance, we are talking about the opposition of motion in space by air. So if we talk about the friction, it is the position of motion between two objects. So you see that if those two are negligible, that means that it is only acceleration due to gravity acting on that body. But then there is a point where it is not, the two are not negligible. That one we shall see it in another case. But here we are just taking it to the two to be negligible, and it is only and only acceleration due to gravity acting on our body. So if you look at free falling, you will see that during this period when the body is moving upwards or downwards, it does not depend on its mass. That means that the mass of the object does not actually affect the motion of that body. Because if you check at this, the first time when we were trying to see how acceleration is equal to acceleration due to gravity, we see that there is no mass factor here. But when we reached here, the mass of the object cancelled off. So it is totally not depending on its mass. So also this falling, in free falling, the whatever is also not considered the shape of the object. So that means that when the object is under free falling, it doesn't matter whether it is circular, it is triangular, or whatever shape it is carrying. When this acceleration due to gravity is acting on it, it does not affect anything and change anything about the motion of that body. So if we say that the shape and the mass of the body does not affect the body. So what happens is that it is only the velocity with which the body is moving. The initial velocity can affect the motion, the final velocity, and the acceleration due to gravity. If it is acceleration due to gravity also affecting the body, how would you find it? We find out that acceleration due to gravity actually acts on each and every body at the same rate, because the surface of the earth, we say that acceleration due to gravity is equals to what? 9.8. But then we can, for matters of calculation, we can round this off to 10, taking it as 10. But doesn't mean that every part has that. This acceleration due to gravity also varies from location and the altitude of the place. But the variation is not that much. It is just very slight. So it is not a must that every time we shall be having 10. It will depend on the location of the object, because there is a situation where there is no acceleration acting on any object. For instance, when a body reaches the surface of the earth, and then it is given a velocity known as the escape velocity from the surface of the earth, what happens is that the body does not experience any effect of this gravity. But then the body will just be floating, because there the gravitational force is very, very weak. So we cannot say everywhere we go we have the value as 9.8. So we should be knowing that in free-falling objects do not encounter air resistance, and also all free-falling objects accelerate, but the acceleration there is the acceleration due to gravity. So those are the two major points in free-falling objects. And also we should remember that when you're talking about free-falling in physics, we do not only mean that it falling down, but it also can be falling upwards. So that is the sense of free falling in physics. With that, we come to the end of our lesson for today. We shall meet again in the next lesson.